Hi everyone, and welcome to day 3 of working from home, the remote school stuff. All right, so we are experiencing some technical difficulties with Schoology. If you've been experiencing that, try and access Schoology maybe earlier in the morning, later in the evening when traffic is a little bit lower. It's struggling to deal with all the number of students who are trying to log in at once. So the last lesson we looked at rectangles and rhombi in terms of their properties and then how we could solve different questions about those shapes using the properties. Today we are going to move on to kites and squares. This will complete all of the quadrilateral shapes that we're going to be looking at in this unit, and it's also going to finish off our week. So when you are done with the lesson today, I want you to focus on the Khan Academy work and getting those posters done. That will be all due on Friday. So essential questions for today. What is the difference between a kite and a delta kite? So there are two different types of kites. What's the difference between them? Something I want you to figure out by the end. And then how is a square related to all of the other quadrilaterals? Okay, so this is where we left off. We had quadrilaterals, which trapezoids are a subset of that, isosceles trapezoids further down, parallelograms, rectangles, and rhombi. So we are left with 3 shapes, and we are going to look at kites first. And then we'll follow on with delta kites. All right, so a kite, how we make it, it is going to be almost 2 isosceles triangles back to back. So if we look at the diagram, we're going to have an isosceles triangle up top, and then another one below it. So that's how we get that kite shape. In terms of properties, we've got 2 pairs of congruent consecutive sides. Another way to say that would be congruent adjacent sides. So as opposed to opposite sides being equal, which we saw in most of our shapes so far, we're now talking about adjacent or consecutive sides being congruent. The 2 angles across from each other between the sides that are not congruent, those are the ones that are going to be congruent. So there's 1 pair of congruent opposite angles. And then the other pair of angles, the diagonal that connects the 2 of them actually bisects those angles. So there's a lot of kind of different properties going on in kites here. They're a very different shape to the ones we've seen so far. The diagonals are perpendicular to one another. And we have 1 line of symmetry, and that in this case, in the diagram's case, is the line going straight up down. So it's the one that divides the 2 isosceles triangles in half. No rotational symmetries in a kite unless a very specific circumstance happens to be there, which is when the kite is in fact a rhombus. So if all 4 sides were congruent, it would still be a kite, but it would technically also be a rhombus, and that's when you start seeing more symmetries pop up. It forms 2 isosceles triangles. We've talked about those, the one on the top and bottom, and then 4 right angle triangles. So if the diagonals are perpendicular, that means that we've got 4 right angle triangles in there, 2 pairs of congruent right angle triangles. So the 2 on the bottom are congruent, the 2 on the top are congruent. And then you also technically have 2 scalene triangles. So that would be, if you use the line of symmetry to divide the shape in half, those 2 triangles created would be scalene, so 3 different side lengths, but congruent to one another. And mention this right, long diagonal bisects the angle. So it's typically the longer of the 2 angles is the one that will bisect the angle. Okay, so 2 different types of kites. Very simple. One is your standard kite that you think of, and then the other one is the delta kite. And the only difference between this is instead of it being an outward shape, it actually comes back in on itself. So what we get is a reflex angle in a delta kite. In your standard kite, you will have typically 2 acute, 2 obtuse angles, but there'll be some combination of acute and obtuse angles. You can end up with 1 obtuse and 3 acute. You can end up with 2 obtuse, 2 acute, and so on. And in the delta kite, you will always have this 1 reflex angle, so it is a measure greater than 180, less than 360. And as a result of that, the other 3 angles are going to have to be acute angles. And when you think of like the kites that you go out and fly, your standard kite is kind of your more basic kite, and then the delta kite is usually the shape you'll see when you start talking about like stunt kites. Okay, question we can try and answer about kites. So if you are seeing the video, pause it and try and answer this on your own. Once you are done, you think you've got an answer, unpause and look to see how we solved it. Okay, so to solve this one, properties of a kite, we know the pairs of adjacent sides are going to be congruent. So PQ and QR, and then PS and RS. We also know the diagonals will be perpendicular, so that's going to be an important one here. We know the diagonals are bisected, and we know that the angles get bisected too, if that ends up being an important thing for us to know. All right, so to solve for x, we know those two sides are going to be congruent, so we can just set these up and solve as if they were equal. So 4x minus 11 equals 3x plus 5. Subtract the 3x from both sides, we get 1x. Add 11 to both sides equals 16. So x is 16. Nice, easy one. And then the angle that 6y minus 12 is equal to, that's also going to be a right angle, so we're going to be able to just say, okay, this is 90 degrees, so 6y minus 12 is going to be equal to 90, and that means 6y is equal to 102. Divide both sides by 6. Y is equal to 102 divided by 6, which is 17. Simple as that. So if you have questions about it, please add it in the discussion for this section. When you're creating questions for yourself, make sure you're using the properties of kites. So think about it. You've got 90-degree angles, you've got right angle triangles. There's a lot of Pythagoras' theorem stuff you could do in here. You've got isosceles triangles, so you can kind of set up solving for missing angles using that kind of logic. There's a lot of different ways you can go down this path for trying to create questions for kites. Okay, so we've got our kites. And you can kind of see now that rhombi is below kite, and we actually do draw a line connecting those. So a rhombus is a very particular type of kite. It is a kite where all four sides are congruent. So a rhombus is actually a subset of parallelograms and kites. And then finally, we get to square. So a square, you can see the lines connecting. A square is a rectangle. It's also a rhombus. It's also a kite. It's also a parallelogram. It's an isosceles trapezoid. It's a regular trapezoid. It's quadrilateral. Like, it is everything. So it has all of the properties of all the shapes. So let's check out and see what else. All right, when you look at squared, we can see the properties outlined on the diagram. So some of the properties that already existed from other shapes above it. Opposite sides are still congruent. Two pairs of congruent adjacent sides, that was our kite property. All sides are equal, there's a rhombus. Opposite sides are parallel, so still true, just like it was in a parallelogram. Opposite angles are congruent, so we saw that in a parallelogram as well. And then the adjacent angles are still supplementary. So if opposite sides are going to be parallel, adjacent angles will still have to be supplementary. All the angles are equal to 90 degrees, so there's our rectangle property coming in. Of course, that also means that diagonals are perpendicular, just like a rhombus. The diagonals bisect the angles, just like a rhombus. The diagonals are congruent, just like a rectangle. The diagonals bisect each other, just like in a parallelogram, rectangle, rhombus, and so on. And then finally, we get down into what makes a square as well. So there are 8 isosceles right angle triangles. So there's 2 different types. There's the larger one that makes up using half of the square, so it uses the full diagonal. So there's 8 of those, and then there's also going to be 4 of those, and then 4 smaller ones as well, where the diagonals intersect each other, like makes up 4 other right angle triangles. And then we've got 4 lines of symmetry. So a square is a regular polygon, which means all sides are congruent, all angles are congruent, and the number of lines of symmetry and rotational symmetries will also be equal to the number of sides. So we've got 4 lines of symmetry. You've got the diagonals, just like in a rhombus, and then you've also got the the perpendicular bisectors of the sides, just like in a rectangle. So those will be your other lines of symmetry. And the rotational symmetry, 360 degrees divided by 4 is 90 degrees. So every 90-degree rotation is. All right, so here's our question about a square. We have to solve for x, y, and z. So we've got x down here in the corner. And if you think about it, the diagonal bisects the angle. The angle is 90 degrees. So if the angle gets bisected, that means each half of it must be 45 degrees. So starting with x, that means 7x minus 4 is equal to 45 degrees. So 7x is equal to 49 degrees. X must be 7. So then moving on to y, if this number here is 9, so half the diagonal BE is 9. Well, all of those are also going to be 9 because the diagonals are bisected and they're congruent. And we've also got diagonals intersect at 90 degrees. So we've got an isosceles right angle triangle where two sides are 9 and we need the hypotenuse. So if we set it up that way using Pythagoras theorem, 9 squared plus 9 squared is going to be equal to y squared. So that's 81 plus 81 is equal to y squared. So that is 162 is equal to y squared. Now if you do the square root of that, so we're rounding to the nearest hundredth. So we will eventually start looking at how we keep these in square root form, but for now we're just going to actually calculate in decimal form. So that is 12.72. And 727, so that will be approximately equal to 12.73 when we round. Okay, now we've got 2z plus 12. Now this one's easier because we can already see like, oh, the half diagonal is 9, the other half's 9, so the total length must be 18. So we just set it up and solve for z based on that. So 2z plus 12 is equal to 18, which means 2z is equal to 6. Z must be 3. So x7, y is 12.73, and z is 3. All right, that brings us to the end for today. Nice short one today. Essential question, what's the difference between a kite and a delta kite? A delta kite is going to have one reflex angle inside of it. So it still has all the properties of a kite, but the only difference being there is also going to be a reflex angle in there as well. How is a square related to the other quadrilaterals? A square basically has all of the properties of all the other quadrilaterals. The only one it doesn't have is the delta kite. So it does not have a reflex angle. It's not possible to make a square with a reflex angle. For tonight and for the rest of the week, I want you to try and make sure you got your Khan Academy assignments done and you've got your posters made. So as soon as you have your posters made, you can post the pictures of those onto the Schoology assignment. I will be opening that up by the time you see this video. I'll see you guys next week. Please send me messages, put in discussions, any questions that you have.